Alright, hi Yifei. In this video I'm going to explain the ideas, challenges and knowledge for assignment 1. For my basic knowledge, as the lecturer explained in STEM, we can use the assessment code for our assignment, as we can literally copy it exactly the same for the assignment. So I copied from the adjacent list. Yeah, so I copied from the add vertex, contains, num edges, get vertices, remove vertex, add edge, and get neighbors. And so for the first problem that I need to solve is the adjacents. Alright, for this one, first I need to check if the vertices exist, and if it does, I also need to check if the list contains the same outcome. If it doesn't, I'll return true. If it does, I'll return false. Alright, for the next one will be the remove edge. There you go. So the basic idea is basically the same as the adjacent. I need to find if the vertices exist, and then if it contains the same value as the end, I need to erase it. Third one will be both in degree, out degree, and degree. So in degree and out degree is basically the same. I just need to set the initial to 0, and then if it contains any vertex in it, I'll just use I as 0 and then pick up the size. If the value of, so basically you need to find the vertex in the adjacent list. If it's contained, yeah, +1. If it doesn't, just return it. So for the degree, it's basically just adding up the in degree and out degree. So yeah. Alright, so okay, so this is the first problem. The first hard problem in my opinion. The get second order. So for this part, I got an insight from the discussion page on STEM on how to do it. So first, I checked if the vertex exists. If it does, you need to push back. Yeah, there you go. And then check the first neighbor for second, and then second order, get first neighbor, get the neighbors and add. And then for J, I use as the second order. So if the first neighbor not in second, as it's in here, and then you need to add neighbor, and then return it. So reachable. This is actually really hard. I don't know how to do it. I also find it on the internet. So reachable. Check if the int empty is not empty. There you go, and then push it back while it's empty. So push it back, and then for each neighbor, if the neighbor ID can link to each other, basically they are reachable. Alright, so depth first and breadth first. So I got an idea here from the week 5 lecture notes, and I use it by iterative method. So for the depth first, I use the stack, and breadth first using queue. So first the breadth first, pick a vertex and put in the queue, then visit all places, place all its neighbor in the queue. And in my opinion, so I just copied the depth first and breadth first. They got the same code. The difference is only one's using stack and the other one is using queue. Alright, so as you can see, I tried to do the out 3 by looking at the week 6 practice question number 2. I tried to do it, but as you can see, it doesn't work. It doesn't want to run. And I also doesn't have enough time to do the transversal. So yeah, feel pretty bad about it. And then last one will be the sorting. So I used week 7 notes and use inserting method. But yeah, so using get all vertices and then using the inserted sort by while sort blah 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 blah. And if I run it, well, I can't even run it. Okay, so basically I got 10 out of 12. Thank you.